And now when we come to multiple bounds and the wildcard extend forms, everything works pretty much as you'd expect. Here we got this generic class Gn here, which has got type parameter t and type bounds of L and K. And down here in green I've shown all those types which are subtypes of K and L, the two bounds. And down here we've got all those types which extend F, and here we've got all those that extend Q in this inner blue area there. And you can see from this pretty obviously that we're going to have it's going to be the case that Gn of something which extends F is going to be a super type of Gn of something that extends Q. And that's exactly what you'd expect, and as far as I can tell, this all seems to work perfectly fine. Now, there doesn't seem to be any bugs in the Sun reference compiler, at least none that are obvious as far as I can tell. Okay, so what about things like Gn of something that extends Z, where Z is like ABC, or KLD, or M or P? Well, if it's any of those, it does exactly what you'd expect it to. So, for instance, if it was P, you'd end up with Gn of something which extends P would just pull out the S there. So the only thing you could set that to would be Gn of S. If it was K, I think it pulls out all of those which are in green would be pulled out, because it does the intersection of the all those types which are subtypes of K together with the those which satisfy the bounds, so it's going to be all those green ones. Okay, so what about when Z was E? Z is E, like that. Then there's a bit more you have to think about, because Gn of something that extends E, if E is marked as being final, then the compiler knows that there's going to be no subtypes of E because it's marked as final. And so therefore what it does is it gives a compiler error. Now if it's not marked as final, then the compiler decides that, well, there may be some subtypes that I haven't yet found, so it still allows that form in. Although of course in this particular hierarchy there's not going to be anything you can set Gn of something that extends E to, well, apart from something like the null or something like that. So it's not a very useful type in this particular case, right? So basically, don't be too misled by the diagram. For instance, Gn of something that extends S and would be just allow you to have Gn of S, and Gn of something which is super S again would just allow you to have Gn of S. And it may seem on the face of it that those two are the same type, but they're not. There isn't, because well, typing relationships like this are all determined at compile time, and the compiler has to allow the possibility that S may have some subtypes which it hasn't yet encountered. And because you've got to allow for that possibility, the extend form, Gn of something that extends S, may include those as well. So because it's got to allow for that possibility, the two types are different, and they can never be the same because of that. Now, you might say, well, what if S is marked as final in this case? Well, I'll say some more about that later. But in fact, even marking it as final doesn't help you, and I'll come to that later. So just keep in mind, always allow the possibility of the thing being extended with something else, having a subtype.